Everybody, welcome to another round of our Maple Systems webinars. My name is Zach here with Maple Systems. For those of you joining us who have been to our previous webinars, thank you for coming back. Very happy to have you and appreciate you coming back. And for those new, thank you all for joining. Very excited for this one. If you are curious about our previous webinars, feel free to check those out on our YouTube page. You can just go to youtube.com or the YouTube app and search Maple Systems. You can find those there. We have a webinar on our web HMIs as well as our Maple Systems PLC product line. So go check those out if you're curious. Today we're going to be talking about our remote IO product line. Very excited to introduce this to you. It's been out for a little while, and we're just happy to kind of give a better representation of what this product does and how simple it is and how easy it is to integrate into your already existing applications. So we're going to go over a lot of that, a lot of case studies, and show you a little bit of a demo at the very end of the presentation, just how easy these are to configure and wire and connect over Ethernet. So stick around for that. It's going to be really great. The way this is going to work today is we're going to watch a quick presentation hosted by myself. In the middle of that presentation, we are going to go ahead and pause a couple different times for questions. You'll see I put a message in the chat there on the right. So if you have any questions at all during the presentation, just go ahead and fire away in that chat. Don't be shy at all. We really appreciate all the questions you may have. It's very helpful for us as a company to get those questions and any type of feedback that you may have. At the end of the video, like I said, we're going to do a quick demo. So really want you all to stick around for that. It's going to be a lot of fun. Presentation is going to be really informative too. So again, just enjoy. And if you have any questions, please fire them away. But without further ado, let's go ahead and get the ball rolling here. Hi, my name is Zach, and I'm with Maple Systems. And today I will be talking to you all about our remote IO model line. Here's a brief overview of what we will be discussing today. First, we are going to define what exactly remote IO is. Next, we will break down the differences between remote and local I/O, then explain how remote I/O works. Then we will discuss the benefits of remote I/O, including how it can extend existing I/O, be used in remote locations, the different protocols that we have to offer with our remote I/O, and how it can be cost-saving. After that, we will discuss some common connection methods, including connecting to remote I/O via Modbus and Ethernet IP. Then we will go over a few case studies to illustrate some examples of how remote I/O can be used in real-world applications such as conveyor belts, water treatment plants, as well as soft PLC functionality in operation with an industrial PC. Finally, we will review all the hardware for our remote I/O product line, including the couplers and expansion modules. Remote I/O has many uses within the industrial automation field, but before we dive too much further into that, let's first start by defining what exactly remote I/O is and how it works. Remote I/O simply refers to I/O devices that can be installed in a remote location that is further away from the application's main PLC, while also still maintaining a strong connection between the main PLC and other field devices. Remote I/O allows applications to be set up in the most effective manner where users will not have to worry about reduced signal quality or expensive and overly complicated wiring requirements. In addition to this, the maintenance of remote I/O is much simpler since users will not have to trace long cables to isolate an issue. Also, remote I/O is great for extending the already existing local I/O within the same cabinet. We will go over these types of applications in more detail later. Although remote I/O is not always needed in every application, it is very common and remains beneficial to these solutions and can complement the local I/O immensely. Let's briefly talk about the difference between local and remote I/O. Local I/O refers to devices that share a direct connection to the main controller or field devices within a short distance that are generally within the same control cabinet or close by. There are several characteristics that we look at when evaluating both local and remote I/O. Some of the key considerations include proximity, wiring, latency, reliability, maintenance, and cost. With local I/O, as we mentioned, the devices that are connected are generally attached to the PLC, which can sometimes limit the installation flexibility. Latency used to be a bigger factor with local versus remote I/O. However, with modern Ethernet protocols and networking, this is no longer the case. Cost-wise, local I/O can be expensive, especially as the system grows. However, our remote I/O price point offers a more manageable and cost-effective solution for implementing extra devices throughout your facility. For remote I/O, devices can be located much further away from the main controller. This offers an increase in flexibility across larger or more complex facilities. With the use of network cables or field bus systems that accomplish the connection of remote I/O, this greatly reduces the amount of wiring required for long distances, which in turn simplifies the overall system architecture. Again, with modern communication networks and Ethernet protocols, the latency from remote I/O is comparable to that of local. In addition to this, remote I/O is generally simpler to troubleshoot and expand given the modularity. This also helps cut costs since remote I/O requires less cabling when needing to expand an existing application. This makes our remote I/O devices a cost-effective solution when compared to high-cost standalone PLCs. Let's talk about exactly how remote I/O works now. If we take a look at the diagram on the left of your screen, we can see an illustration of a remote I/O device topography. You will see at the top that we have our HMI, which is talking to our main PLC and local I/O. From there, the local I/O branches out to all of the remote chassis, each at its own station. Within each of those stations, each remote I/O chassis is communicating to different field devices, making them able to extend functionality throughout the facility. The communication flow from these devices is not limited to one direction either. Data can be sent and received from all devices in the diagram. Implementing remote I/O requires a dedicated communication port on the main PLC, which can either be a built-in master communication port or an additional communication module. In our diagram on the left, we are using a Maple modular expandable PLC for this application, which has an expandable Ethernet module that will allow the PLC to communicate with other devices as a Modbus TCP IP master device, while also still acting as the Modbus TCP IP slave to the HMI. We will discuss this in more depth later. The HMI is able to communicate to the PLC, which is connected to the local I/O, controlling nearby devices. Then, with the Ethernet expansion module on the PLC, it is able to communicate over a larger network to the remote I/O chassis, which in this example also communicates via Modbus. These remote I/O chassis can be much further away from the local I/O as long as they are within the range of the Ethernet network at the facility. Then finally, from there, the remote I/O each controls their own independent station, thus spreading more I/O throughout the facility. The communication module serves as a bridge which then transfers all processed data to the PLC through a single cable. Now that we know more about what remote I/O is and how it works and differs from local I/O, let's discuss some of the key benefits of implementing remote I/O into your facility. Remote I/O can function as an extension of your local I/O. As we have discussed, PLCs with local I/O could be expensive initially and then continue to go up in cost as a facility grows its application. For high-cost PLCs that have expandable local I/O, each expansion module needed is not cheap. However, since our remote I/O is low cost compared to expandable local I/O modules, you can opt for our remote I/O, which can then extend the current PLC and local I/O chassis just as effectively. Also, since our remote I/O does not require any programming software, they can function as an easy plug-and-play solution. As mentioned previously, remote I/O is perfect for also extending local I/O into more remote locations. Given that local I/O is dependent upon smaller and more constrained environments, remote I/O can easily be placed throughout your facility, which acts as an extension of application, since each remote I/O chassis can allow control of different stations throughout the facility. To further exemplify this, we can look at the use of analog sensors. Analog sensors can be used for measuring volumes in tanks, ambient pressure, or temperatures, just to list a few examples. The further the wires from the analog sensors have to travel to reach the PLC and local I/O, the less accurate the readings can be, which can greatly affect the outcome of the application since those readings need to be precise. With the use of remote I/O, you can keep the I/O as close as possible to the analog sensors, thus making readings the most accurate as well. Let's dive a little deeper with a simple, real-world example involving thermocouples and cold junctions to highlight why this is so important. When working with thermocouples, one common challenge is dealing with cold junctions. These occur when thermocouple wires are run over long distances or have multiple connection points before reaching the local I/O. Each time the thermocouple wires, made of dissimilar metals, connect to copper terminals such as those found on PLC or local I/O modules, a new cold junction is created. Every additional cold junction introduces the potential for inaccurate readings due to temperature variations at those connection points. These inaccuracies can ripple through the system, causing bigger problems for the entire facility. Fortunately, remote I/O offers a practical solution. By placing the remote I/O much closer to the thermocouple's actual location, you minimize the wire length and reduce the number of unnecessary connections. Fewer connections means fewer cold junctions, which significantly improves measurement accuracy. This leads to more stable and consistent readings, critical for any facility that depends on precise temperature data. For example, water treatment plants, which we will discuss in more detail later, rely heavily on accurate temperature and process measurements to operate effectively. Remote I/O offers several different communication protocol options, which make them very versatile in implementing into an already existing application. For example, if your entire facility communicates via Ethernet IP protocol, then you may not want to add a remote I/O that communicates via Modbus. Instead, you may want to pick one that supports Ethernet IP. Here are the communication protocols that our remote I/O modules have to offer and some of the most common PLCs that would use said communication protocols. First, we have Modbus. Modbus is one of the most common universal communication protocols used in industrial automation today. Our own Maple PLCs communicate via Modbus, as well as many other well-known manufacturers. Next, we have Ethernet IP. Ethernet IP is another very common communication protocol, mainly because it is the primary communication protocol used by Allen Bradley. It is also used by several other PLC manufacturers, such as Omron. The next protocol is EtherCAT. EtherCAT is most popular with Beckhoff PLCs as this is their main communication protocol used and was developed by them, although many other PLC manufacturers use this protocol now as well. Lastly, we have CANopen. This communication protocol is increasing in popularity and can be seen in use with PLC manufacturers such as Schneider. In addition to all of these benefits of remote I/O, one of the most important is that remote I/O can be cost-saving, specifically with our Maple Systems IR remote I/O modules. All right, we are going to go ahead and pause there for our first break of this presentation. I do have a couple questions I want to address here before we move on. First question here looks like regarding the cold junction section that we just talked about in terms of what the maximum length of wiring for an analog sensor would be before you start to see some signal loss and deterioration. Kind of a tough question to answer because there's not like an exact length. You'll hear 100 feet a lot of the times for that before you start to see it. Really, it's going to be dependent on the brand of the sensor that you're using, the type, obviously, something like a thermocouple versus a pressure sensor or a water level sensor, something like that, are all going to be a little different. Biggest thing to look out for is if you start to see some serious loss in signal quality, that's probably when it's about time to implement remote I/O. Ideally, you want to keep that analog sensor just as close to whatever you're measuring as possible. So to keep that closer to the remote I/O. If your PLC is in one section of the building, you don't want to run hundreds of feet of wire because, again, that's just not going to be ideal for an accurate reading. Next question that I have here is there a limit to how many remote I/O couplers you can have? So on our end, the limit is just going to be dependent on the PLC brand that you're using. So for example, if you're using an Allen Bradley PLC, you'd want to check the specific manual for that PLC, whether you're using like a compact or a Control Logics or an older Micro Logics, on how many how many slave devices it can talk to as a master communicator. Because in this case, the PLC will have to act as a master device to communicate with the remote I/O couplers since they are slave-only devices. So you want to double check that, they usually have some sort of limit. I don't know off the top of my head what an Allen Bradley master PLC limit would be, but just be sure to check that. As long as you're within that limit, you can just have that many different couplers as you'd like. So pretty nice there. We are going to go ahead and roll along here. We'll have another break in a little bit. So any more questions, please feel free to keep firing them away. These have been great so far. So appreciate that and enjoy the rest of the video here. Before we move on to discussing some specific case studies on remote I/O use within an actual industrial application, let's first discuss a couple of the most common communication protocols within remote I/O use. The first communication protocol that we will look into a bit more is Modbus TCP/IP. As I mentioned previously, Modbus is one of the most common communication protocols within the industrial automation field and has become widely adopted by many well-known manufacturers. Most devices you choose to implement into your applications will have Modbus compatibility. In the case of remote I/O, we have 3 different I/O couplers that offer Modbus compatibility, which we will discuss more later. Since our Maple PLCs all communicate via Modbus TCP/IP, they make a perfect fit to pair with our remote I/O couplers that are also Modbus compatible so that you can easily extend your local I/O further throughout your facility. In this example, we will use a Maple Modular PLC and an IR-ETN remote I/O coupler. For the Maple Modular PLC, we are going to use Maple Logic, which is our proprietary PLC programming software, which is also free to use. This will be to create the PLC project in order to control the application through the local and remote I/O. Generally, remote I/O configuration is done on the hardware through dip switches and dials. However, we offer a more streamlined solution with our configuration software, Easy Remote I/O. Easy Remote I/O allows you to set the IP address of the remote I/O coupler as well as configure your communication protocol, in this case Modbus, and configure any analog I/O that may be in use from an expansion module connected to the coupler. Since Modbus is so common in industrial automation, it has been adopted by many other manufacturers such as Allen Bradley and Siemens. Primarily, these manufacturers communicate through their own proprietary protocols. For example, Siemens uses a protocol called Profinet. However, Siemens PLCs can also communicate via Modbus, which makes our remote I/O a compatible solution with Siemens PLCs. For this example, we will still use an IR-ETN coupler, but instead with a Siemens PLC, this time such as an S7-1500. Easy Remote I/O is still an option here as well to easily configure the IR-ETN, and the Siemens PLC would be programmed using the Siemens TIA portal programming software. The implementation of this setup is simple. All you will need to do is configure your PLC as a Modbus TCP/IP master device and the remote I/O as the slave device. We can see this device and network topography in the diagram on the left. Similar to the previous topography diagram shown earlier, the local I/O and remote I/O are connected to the same network via Ethernet switch. In this example, the PC is shown as well to configure and download to both devices. Some of the benefits of communicating via Modbus, as we have briefly touched on, are its simplicity, compatibility, and flexibility. Given how long Modbus has been around in this industry, there is a bounty of resources and knowledge on the basics of Modbus communication, and has become more or less a standard to adapt for many manufacturers, making implementing Modbus devices seamless. Another common communication protocol that you will see a lot within industrial automation is Ethernet IP. Ethernet IP has been made popular mostly due to its common use in Allen Bradley PLCs. Allen Bradley uses Ethernet IP as its primary communication protocol. In this example, we will look at connecting an Allen Bradley PLC to our Maple Systems remote I/O via Ethernet IP. We will specifically use a Compact Logix and Control Logix PLC, as well as our IR-ETN remote I/O module once again. In addition, we will use Easy Remote I/O configuration software for the IR-ETN, as well as RS Logix 5000, which is the PLC programming software for the Allen Bradley Compact and Control Logix PLCs. With most Ethernet IP devices, a file called an EDS file is required from the slave device to the master device so that the I/O from the slave device can be imported into the master device and then mapped within the logic of the master PLC, in this case the Allen Bradley PLC. Extracting and importing this EDS file is simple. You will generate the EDS file from Easy Remote I/O and then import it into the RS Logix 5000 PLC program. This allows the PLC to communicate directly with the remote I/O. Here on the left, you can see how the network topography will look for this application. As you can see, it is just about identical to the Modbus network topography. The benefits of using Ethernet IP as a communication protocol are that the speed and bandwidth can run at high data transfer rates and handle larger amounts of data, which are ideal for applications requiring real-time control and monitoring. The scalability, which supports a wide range of devices and network sizes, diagnostic and monitoring capabilities, since Ethernet IP provides advanced diagnostic tools and monitoring capabilities, and standardization, as Ethernet IP follows widely accepted IEEE 802.3 standards. In addition to this, adding multiple sets of remote I/O is simple and easy through the use of the EDS files that we discussed previously. Now that we have a better understanding of what remote I/O is, how it works, and some popular communication protocols that it uses, let's discuss some case studies on how one might see remote I/O being used in the real world. We have 3 case studies that we will look at that will best illustrate some ideal industrial applications in which remote I/O would be a seamless fit. The first case study we are going to look at will be applications with conveyor belts. Conveyor belt systems are a big part of many industrial automation applications, especially in online shopping facilities, food and beverage industries, but also as part of any industry that deals with assembly on a day-to-day basis. Conveyor belts make an assembly line seamless and efficient. However, many conveyor belts could stretch across an entire facility, making the use of just local I/O not the most efficient. This is where the remote I/O implementation comes in. As we have discussed, local I/O can only stretch so far across a facility before it starts to become cumbersome and latent due to long and complicated wiring schemes. If we take a look at the diagram on the left, we have a few different devices in action within this application. We have an HMI connected to a PLC with local I/O attached, then we have 2 sets of remote I/Os. Each set of devices controls its own unique station across the conveyor belt. In this example, we are looking specifically at a bottling line. There are 3 different stations. The first station controlled by the local I/O, which is the sanitization station. The second station controlled by the first set of remote I/O, which is the capping and filling station. Then the third and final station controlled by the second set of remote I/O, which is the end-of-line packaging station. In a real-world application with the use of remote I/O, this application could stretch all throughout a massive facility and still be able to cover all essential stations necessary to the bottling procedure and in a cost-effective manner. The next case study that we will look at as an example of remote I/O usage will be a water treatment plant. The main theme of implementing remote I/O is to further extend I/O throughout your facility in places that are far from your local I/O. Similar to applications with conveyor belts, a water treatment plant fits this mold perfectly. Within a water treatment plant, it is not only common for the stations of the plant to be far away from each other, but also to be in completely different buildings on the plant site. Given this distance between stations, remote I/O not only becomes ideal, but also necessary in most cases. Because analog sensors are a necessity within water treatment plants, in order to measure tank volume or pH level as an example, remote I/O becomes even more important. As we discussed previously, the longer the wires run from the PLC and local I/O to any analog sensors in use will have a negative effect on their reading accuracy. Thus, having remote I/O closer to the analog sensors, decreasing their wire length, helps keep those readings as accurate as possible, leading to smoother operations throughout the facility. If we look at the diagram on the left, we will again see a few different devices, including the local I/O, which is the Maple Modular PLC, and 3 sets of remote I/O chassis. In this illustration, there are 3 stations that the local I/O is connecting to in order to control. The first station is the coagulation station, which will use digital and analog I/O from the remote I/O to control pumps, motors, and mixer speeds. The next station is the flocculation station, which will utilize analog sensors connected to the remote I/O to monitor flow and turbidity meters as well as digital outputs to adjust valves. Then finally, the filtration station, which will utilize analog sensors on the remote I/O to monitor flow meters as well as digital outputs to control pumps. Our third and final case study that we will be discussing today revolves around using an industrial PC as a soft PLC to connect with and control remote I/O. For this type of application, we will use an industrial PC, or IPC for short. The IPC will host the project that will ultimately be controlling the devices that are connected via the remote I/O, which means the IPC will be acting as a soft PLC which processes code to the remote I/O. This leads us into the question, what is a soft PLC? A soft PLC is a software-based PLC that runs on a computer architecture such as an IPC and other similar devices versus a dedicated PLC CPU that connects to local I/O. Since most IPCs do not include built-in I/O, remote I/O becomes a perfect pairing to communicate with desired devices. In this example, the IPC is acting as a soft PLC using programming software such as CodeAssist, TwinCAT, or any other coding application that can communicate over one of the previously mentioned industrial communication protocols to speak with the remote I/O. The IPC itself does not have a proprietary programming software like a PLC would. However, it can use other softwares like CodeAssist, which is a PLC software, or TwinCAT, which can communicate over industrial protocols. By using this third-party software from the IPC, you can generate code to control I/O directly from the remote I/O without any existing PLC and local I/O in use. Earlier, we briefly discussed the 4 different communication protocols that. All right, apologies for the late stop there. We're going to go ahead and pause it here, though, really quick before we finish this out. We just have a few minutes left. We're going to go over the actual hardware, all the 5 couplers that we have to offer, as well as all the additional expansion I/O modules. Did have one last question here, wanted to address before we move on. Question regarding error diagnostics. And whether or not our IR modules offer error diagnostics. So fantastic question, and yes, they do. So all of our IR modules, including the expansion modules, all have LED lights. On those is going to be a specific error light. If there is an error, that will be blinking red. That will indicate that there is some sort of error with the module or the coupler itself. If that does happen, you can connect that to the Easy Remote configuration software, which we will showcase here in a little bit as well when we do the demo. And that will tell you what error code you're getting, and then you can look up that error code in the IR module manual. That will tell you what's happening there. In my experience, as someone who has worked in tech support here, supported these for quite some time now, the only type of error I've ever really run into is going to be due to lack of power or a wiring issue. So it's usually just a really simple fix of moving a wire from something that's not grounded to grounded, or the power just not being plugged in properly. So not a lot to get into there, really. All right, we are going to go ahead and finish out this last little part. Like I said, we just have a few minutes left here going over the hardware, and then we will jump right into the demo. Again, thank you for all the questions. If there's anything I didn't get to, we'll try to get to it at the end. And if not, I can always contact you afterwards. So thanks for sticking by here. Like I said, just a few minutes left, and we'll get into that demo. So thank you all for watching here. We have to offer with our remote I/O modules. Now let's showcase the 5 remote I/O couplers and the protocols they use. The first communication protocol we will look at is Ethernet IP. If you wish to communicate via Ethernet IP, then the IR-ETN series couplers will be the best fit. This includes the IR-ETN and the IR-ETN 40P and R. In addition to Ethernet IP, all 3 of these couplers also communicate via Modbus TCP IP. Next, we have EtherCAT. As previously discussed, EtherCAT is a commonly used protocol with Beckhoff PLCs. If you are looking for EtherCAT communication, then the IR-ECAT will be the proper coupler to choose. Lastly, we have CANopen. If you are in need of CANopen communication, then we have the IR-ECOP to offer for this exact application. Now that we have covered the 5 remote I/O couplers that we have to offer, let's briefly go over all the different types of I/O that our expansion modules can cover. With a vast diversity of different combinations of I/O that our expansions have to offer, and that all of our remote I/O couplers can adapt up to 16 expansions, we are sure to have the right combination of I/O that you will need. Our remote I/O expansions offer modules with digital input, digital output, and combinations of both digital input and output. We also offer relay output accommodation as well. For analog I/O, we offer analog input, analog output, as well as a combination of both analog input and output. In addition to standard analog input and output, we also offer an expansion module compatible with thermocouples. Our IR ETN40P and R couplers have built-in I/O already on them, and with that, we also offer high-speed counter implementation. In addition to that, the IR ETN40P also offers PWM, or pulse width modulation. That all but does it for our presentation today. Just to highlight all that we went over again, we defined what remote I/O was and went over some examples of how remote I/O is used in the industrial automation field. We went over some of the most common communication protocols to connect to remote I/O, including Ethernet IP, Modbus, EtherCAT, and CANopen. After that, we went over a few specific case studies to better illustrate some examples of how remote I/O is used. Then we discussed the different remote I/O couplers and each of their communication protocols. And lastly, we finished with a quick review of all the different I/O that we cover with our remote I/O expansion modules. We here at Maple Systems are extremely excited to introduce all these new products and features to you. We invite you to explore even more by going to maplesystems.com and browsing the articles we have put together to illustrate how our remote I/O line can be the newest addition in your setup and how they can improve current operations. You can find these under the Knowledge Center within the Solution tab, then Articles. If you ever have any questions at any time or want to inquire more about our remote I/O, then please contact our sales team through sales@maplesystems.com. And of course, always feel free to call us at 425-745-3229. Again, I'm Zach with Maple Systems, and thank you very much for watching. All right. As the video said, thank you all very much for watching. Really appreciate all of your attendance today, all your engagement with the questions. Super helpful for us, like I said. We are going to go ahead and just hop right into this demo here. If you do have any questions throughout the demo, please still feel free to fire those away in the chat. I most likely won't be able to get to them in the demo just because I'll be interacting so much with the software and the hardware. But I will contact you afterwards so that way we can get those answered. So don't worry, we'll get those answered one way or another here for you. So with this demo, what we're going to do is we are going to show you just how easy these remote I/Os are to set up with our Maple PLC specifically over Modbus TCP/IP. If you are curious about how to hook up these remote I/O couplers with something like an Ethernet IP PLC, please check out our article and demonstration and full-on walkthrough on how to do that on our website, maplesystems.com, under the Solutions tab, and then Articles. You'll find a article on setting up our remote I/O with an Allen Bradley Ethernet IP PLC. I'm going to walk you through how to export the EDS file from Easy Remote I/O, as well as how to import that into RS Logix 5000. It's a really great walkthrough, really great article. So if you have any more questions on that specifically, please check that out. Again, that's at maplesystems.com under the Solutions tab and Articles. All right, we're going to go ahead and move along here, and we're going to get a top-down view of our hardware here first. So what we're looking at here is we have two different chassis. We have our main PLC with our local I/O. For this demonstration, I just have a few different analog modules here. They're just for show. They're not really necessary for this demonstration, but just to show you what a full chassis here would look like with our PLC. What is very important here, and the most important part of this, is our MOD-SENT01 module, otherwise known as our Ethernet module. This is what is going to allow the main CPU and PLC here to actually act as a Modbus master over Ethernet using the Modbus protocol. By default, these CPUs can be can communicate via Modbus only as a slave over Ethernet. So they don't have the ability to act as a master on their own. So you do need the addition of one of these MODSENT01s. You'll see that in some other PLC brands as well, where you need kind of an expansion to give that master functionality. So in this case, that's what we're using. And then over here, we have our remote I/O setup. So I'm using the IR ETN today, just the regular ETN, the one that you've probably seen the most in that presentation there. And then we're also going to use one digital output module and one analog input module. And this analog input module specifically is for thermocouples. So just to kind of simulate what we're looking at today, this is kind of just a small version of what we would look at in a real life application. We're going to have our PLC here. That's going to have all of our programming in it, and it's going to communicate to the pre-mapped internal addresses on this digital module and this analog module to read a signal. For this example, I have a signal generator wired up to analog input channel 0, and it's going to be representing a type J thermocouple. And basically what we're going to show here in a minute, once we take a look at the configuration, is we're going to show how to take the addresses from these remote I/O and map them into this PLC so that we can monitor the analog input and trigger an alarm on this LED from the digital module in case our temperature goes too high. So let's go ahead and take a look at that here. I'm going to go ahead and share my screen. Alrighty. So what we are looking at here is our PLC software, Maple Logic. This is our proprietary software for our PLCs. And we're going to show you how to map those addresses here and show you just how simple this setup really is. And how easy it would be to, if you already have an existing PLC project, to add this in. It'd be very simple. So what we're looking at here again is the base logic that we're going to be referring to. This is a greater than statement. So if D4, this is our analog channel 0 input right here, is greater than 450, in this case 450 degrees, then we are going to trigger this alarm. And this just makes it blink every 1 second. So we have like a flashing alarm. And our alarm is at Y100 in the PLC. So we have this, but how do we get those addresses from the remote I/O? And that is where our Easy Remote I/O configuration software comes in. So we have the configuration software. Again, it's not a programming software. Everything's going to be programmed in the actual PLC with the local I/O. This is just for configuring the remote I/O. And when we say configure, we're talking mainly just about the IP address here. So this is the IP of the IR ETN. So we can communicate with the local PLC here, the local I/O with the PLC. And then there's some other parameters here we'll show in a minute. But the other most important part about this is knowing what our addresses are. So here we have our address table. We have our digital module, the DQ16-P. And since it is just an output module, we're just talking about Booleans. So we know that Booleans are already mapped to the 0x Modbus range. So we're going to start at 0x0 in this case, if we want to read or write to that first output bit. And this is starting at address base 0 in Maple Logic. It's going to start at address base 1. So just remember that here when we go back to the Maple Logic side, that it's going to be offset by 1. And that's something you will want to also pay attention to for your PLC software that you're using, whether you're using Maple Logic or some other PLC software. Make sure to check what your Modbus range starts at in that software so you can adjust if need be. So in this case, we do. And then we have our analog input module here, and these are going to be the 4x range since it's an analog signal. And again, 4x0, 1, 2, 3 would actually be 1, 2, 3, and 4. So that offset. And then over here, we have some parameters. So we have some CPU parameters for the actual coupler. And if we go here to the analog, we can see we can select the input mode. So I have it set to thermocouple type J. There's a lot of different options here for this thermocouple module for you to use and select. You can set the upper limit and the lower limit for the range. We're maxed out at 32,000 on each end here. And then also where you would set the unit of temperature. So right now we have it at Celsius. All right, so we're going to go ahead and jump back over to this. So the main question is we have our logic. So how do we map those addresses we just saw in the Easy Remote I/O software to the Maple Logic software, so we can actually monitor this real value and control real outputs on that remote I/O. So we are going to create a Modbus master scan or program, and to do that here, we would just right-click Program, New Program, select Modbus TCP/IP master. Right now, I'm online with the PLC, so I can't actually click this. It won't let me. I'd have to go offline, but we're just going to say we already have it made right here. So when this first comes up, you're going to have a few options, and all this will be blank. We'll just start from the top down. So the slot, that's referring to the slot that your Ethernet module is in. So if we look over here, our CPU is channel 0, then slot 1, 2, 3, and 4, there's our MOD SENT01. And we have port 502, that's just the Modbus port. You can't really change that, or nor would you really want to. And then the device data server is the IP address of the slave device that we're communicating with, in this case, the IR-ETN. And that's so that's the same IP that we just saw over here. So 150.201. And then here is where we actually will map the Modbus address of the remote I/O into the local PLC here. To do that, you would click Add. I already have a couple added over here, so I'm just going to go ahead and double click on this. And this is what it's going to look like when you first pull it up. So station number, the station number is referring to what slave device you're communicating with. We only have one, so station number is going to be 0. If we had multiple, we could say, let's say we had 3. If I wanted to speak to the second one, this would be station number 1. If I wanted to speak to the third, it'd be station number 2, and so forth. We have the function code selection here for the Modbus function code. If you're unfamiliar with Modbus function codes, there's a lot of good information out there. Thankfully, it's a really universal set. There's not a lot of variation, or if any variation in this. And thankfully, in Maple Logic, they actually explain it pretty well what we're choosing. So we're going to choose function code 3 because we want to actually just read this holding register. It's an analog input. We're not worried about writing to it, nor can we write to it. It's a read-only, read-only address. And then for the address, so we have our 4x address range right there, and our starting address at 1, so 4x1. So again, that's going to read that, if we go back here, that 4x0 right there, even though it's, because it's offset. And then data size, one word, it's a 16-bit register. And then this is where we actually select what address in the PLC we're going to map this to. So in this case, we're going to map it to D0. And then click OK. And then same thing here for the digital module. Again, since it's Boolean based, we're going to choose function code 5, and we're going to force single coil because we want to actually turn that on when that condition is met, which is that greater than condition we just looked at earlier. We know we have it right because we have our 0x range right there, and starting address 1, so that will be configured to that very first digital output channel on our digital output model. And then data size and data type is moot because it's Boolean, and the device that we're sending it to is that address Y100 that we saw. So that's how simple it is to just map those PLC addresses directly to those remote I/O addresses. So before we go on, I do have a little bit of a background logic here that's going on. So as you remember, we mapped the analog input signal to D0. But as you'll see over here, I have it at D4. And the reason why is because we're reading temperature, I want to actually see a decimal value temperature. And the way that it comes into the PLC from the remote I/O is just kind of a large number. It is still the temperature. It just doesn't have a decimal. So it comes in as 4,473 right now, which would just translate to 447.3. But I want to get the full number there, so I want to add a decimal. So I'm going to first convert this to a float because it's a 16-bit address. And then I'm going to store that in D2. So there's my float. Now it has a decimal, but I need that decimal to be moved over. So I'm going to take that float that I have, divide it by 10, and now I have my actual temperature that I'm reading from my signal generator. So it's all accurate and matching up there. And now if we go back over, we can go ahead and raise the temperature on this. So this is all, again, coming from the PLC itself over to the remote I/O. So everything here that we're seeing is being controlled by the main PLC and the local I/O. and then being either read or written to that remote I/O over here on this side to the LED. So let's go ahead and raise this up a little bit. And we will see once we reach that mark, there we go. We're at 450.33 or 399, and now our alarm is triggering. So it really is that simple. The main key here when you're working with any software or ours is that you just need to map those addresses in the PLC to the addresses in the remote I/O, and you're all set. So if you did have an existing application already, you could have multiple blocks of logic and then just set something like this up where those already existing addresses are now just mapped to something on a remote I/O, or you can add in some new addresses. Either way, it's really that simple. We can show you again a larger view here of the hardware. You can see that light blinking. I can turn it off. If I go down a bit and then back on again, everything just communicating from the main PLC here over to the remote I/O with just an Ethernet connection, no wires connected other than that. So pretty cool, pretty simple, but that's just about it. So again, just wanted to thank everyone for joining us today. I had a great time as always. Really appreciate all the attendance, all the engagement, and I hope you really all enjoyed it. If you do have any other further questions, please feel free to contact our sales department through sales@maplesystems.com or give us a call at 425-745-3229. If you have any further technical questions, they can always pass you along to our wonderful support team. They can finish up any other questions that you may have that sales isn't able to answer for you. But everyone here very knowledgeable on this product line. So please feel free to give us a call or send us an email if you have any further questions. Just want to thank everyone one more time. Really appreciate it all. Again, my name is Zach with Maple Systems, and I hope you all have a fantastic rest of your day. Thank you.